Hello students, in this video we are going to learn about Astronomical Telescope. Astronomical Telescope is one of the optical devices used to see heavenly objects like sun, stars, planets, etc. It is one of the types of refracting type telescope. There are two questions we have to learn. One, when the image is formed at the least distance of distinct vision, and another one, when the image is formed at infinite position. Here is a ray diagram. There are two lenses arranged. One is the objective lens having large aperture and large focal length. You can see FO, this much distance. This is a focal length. And another one, eyepiece, which has short focal length. Here is the focus of this. Now, here the object is at infinite position. The rays which are coming from infinite object form the image at this point. This is the focus of the objective lens. The image formed is inverted and it is a point image, A dash, B dash. Now this behaves as an object for the eyepiece. So the eyepiece is adjusted in such a way that this image will be formed between the focus and the center of the eyepiece. And this A dash B dash would form the image here on the same side, that is A double dash and B double dash. It is magnified and virtual, but it is still inverted with respect to the object that is at infinite position. But for heavenly bodies, such observation will not make much difference. Why? Because they are almost round in shape. Now here is FE and FO, and the distance is adjusted within the least distance of distinct vision when you see the object with respect to this position. So the image is seen at D distance. And we know what is the magnifying power. It is a ratio of angle formed at the eye by the final image formed at the LDDV to the angle formed at the eye by the object at infinite position when it is seen directly. So M is equal to beta by alpha. It is nothing but tan beta by tan alpha. And that is now with respect to the diagram, when we do this calculation, it is going to give us FO upon minus UE, because it is going to be OB dash is equal to plus FO, this distance, and B dash E is going to be minus UE. Therefore, our first equation is nothing but the magnifying power. Initially, it is given by FO upon minus UE. Now, with respect to the eyepiece, when we calculate this, what is the object distance for eyepiece? It is minus UE. You can see here, the object position for this is minus UE. And what is the image position with respect to the eyepiece? It is at D position. Therefore, it is minus D, which is written. We can also substitute this in Length's formula. Let us write Length's formula. 1 by V minus 1 by U is going to be 1 by F. Now we substitute these two values in this Length's formula. Therefore, our equation becomes here 1 upon minus D minus 1 upon minus UE, that is going to be 1 upon FE, where this is a focal length of eyepiece, object position with respect to eyepiece, and the image position with respect to the eyepiece, all these measurements. Now, we can also rearrange this step for 1 by UE, that is going to be here 1 upon FE plus 1 upon D. Let this be equation 2 and this be equation 3. Now, we can substitute this equations. This is 1 upon FE plus 1 upon D. You can substitute this equation in the first expression for magnifying power, where FO upon minus UE is given. Before that, we can also rearrange with one more step. 1 upon FE, you are taking common outside and you write here, this is going to be 1 plus FE upon D. This equation can be substituted here. Therefore, you must be getting now the magnifying power of the astronomical telescope can be substituted in this way. FO upon FE, where it is minus, we still substitute this 1 plus FE upon D here. This is the final expression for magnifying power of astronomical telescope at LDDV position. It is what here? FO by FE into 1 plus FE upon D here. Now here also for the large magnification, this FO should be kept much larger than FE. Now we have to discuss about the second case when the image is formed at infinite position. This infinite position can also be termed as normal adjustment position. Here is a ray diagram having two lenses, objective and eyepiece. Here rays which are coming from infinite object that is focused here at one point. At this point, you have the focus of objective and the focus of eyepiece meet at the same place. You can find this point FO and FE at the same point. And these rays form an inverted image, that is a point image, which is obtained at the focus of the eyepiece. Therefore, this behaves as an object for the eyepiece and forms the final image at infinite position. When we look at this object from infinity, the object is also at infinity and the final image is also at infinity with respect to human eye. And this is the focus, that is FE is the focal length of eyepiece and FO is the focal length of the objective lens. And we all know that the magnifying power for this situation at infinite condition is nothing but here the ratio of angle formed at the eye by the final image as seen through the telescope to the angle formed at the eye by the object seen directly when both the image and the object lie at infinite position. You can see here A dash O B dash is equal to alpha, which is labeled here, and A dash E B dash is equal to beta, which is also labeled here, and you can also write here the positions of objective focal length and eyepiece focal length. And we have written the formula m is equal to beta by alpha. When we substitute these values, we must get the final expression, that is m is going to be minus FO upon FE. It is the final expression. After substituting the values of tan beta and tan alpha from the ray diagram, we will be getting this as the final magnifying power of astronomical telescope when the image is formed at normal adjustment or at infinite position. It is nothing but the ratio between two focal lengths. If you see, it is a ratio between the focal length of objective lens and the focal length of eyepiece. This is the final expression. I hope you understood this concept very well. Thank you for watching.